Okay, I just want to show some key differences about doing insert sort the correct way and doing insert sort the incorrect way. And it's actually only one tiny little difference that makes a huge difference in how the function actually runs. So on the left here is an implementation of insert sort. It's not necessarily the best, it's just one implementation, one way to do it. And on the right hand side is an extremely similar set of code with one minor difference that makes a huge that has a huge effect on it. So if you were to run insert sort on 250,000 items, just random on a random array, in that particular trial for 250,000 random items in an array, it took 15.5 billion array transactions hitting the memory for swaps in and out and this sort of thing. That's not including this check right here in the while loop. So it's counting, taking the temporary value from the array, shifting the items in the array, and then placing the temporary value back into the array. Those are the three array transactions that I sort of tracked as I went through this. Now, the way that this works is it will shift as many items that it needs to the right, so shifts them past the current temporary value, and then places the temporary value back into the array once all of the items that needed to be shifted are shifted. And that's the correct way to implement insert sort. But the minor difference is that if you take this one line of putting the temporary value or the current value back into the array, if you take that one line and you put it in the loop instead of outside the loop, you're doing way too many extra array transactions, and what it ends up doing is a bubble sort. So it ends up doing a reverse bubble sort, bubbling the items to the left, bubbling the smallest items to the left. And that one actually takes double the number of array transactions to do. So for the same 250,000 random array, it took 31 billion array transactions. And again, that's just counting, saving the temporary value, shifting items to the right, and then placing the temporary value back into the array. But what ends up happening is the temporary value gets placed back into the array over and over and over again, and it really doesn't need to until that shifting is done. And so that's the difference between these two. So if you've implemented insert sort with placing the temporary value back into the array inside your loop, and for some this wouldn't be a while loop, it might be a for loop, you actually have not coded insert sort. You've coded bubble sort in reverse, and that's actually a big no-no, and it's going to take way too many transactions. Now, of course, with today's computers, how fast they are, it's not a huge difference, but it is in magnitude of double the number of memory transactions that you're going to have there. So that's it. I just wanted to go over those two major differences.